In this segment, we'll look at the design tension between joins and subqueries, and we'll discuss use of subqueries that produce lists of values. So as we get deeper into subqueries, we'll see that there are often ways to replace a subquery with a well-designed join. This is not always so. Sometimes subqueries are essential, at least if you want to perform a task in one statement. But very often you can do the same thing with a join as you can with a subquery. So, question 1 here. As an example, redo this subquery on the Bakery4 database without using this query here, without using a subquery. And note that this is similar to a query you built in the discussion on group by and aggregation. What you'll need for an answer will involve one join and a group by with associated aggregation. Coming back from a pause, let me first run the existing query, and then the answer that I came up with at least looks like this. So what we had here was a query that would select first and last name from a customer and the sum of all of their receipt prices, all the line items in all of their receipts, if it was greater than 100. And down here we get the same effect by joining on receipt and then on line item and product, and then grouping by customer ID having some price greater than 100, and the effect is the same. The relative merit of using joins versus subqueries, in cases where either will work, is a subject of some debate. If you type subquery v, not even vs, at Google, it completes with subquery versus join. Using joins is often more efficient, though this is not guaranteed. Using subqueries is considered clearer by many, but some disagree. It's probably reasonable to say that hardcore SQL writers concerned with efficiency prefer joins, while beginning SQL writers find subqueries easier to understand. You should be able to translate queries from one usage to the other, and we'll have a number of chances to practice that in the upcoming discussion. Now let's talk a bit now about subqueries that yield lists. We've seen the in operator in earlier discussions, for instance, as a convenient way to check whether a state is in a given list of states, state in California, Washington, Oregon. This operator is one of a family of operators, all of which operate on lists of values. And importantly, the lists on which these operators work can be generated by subqueries. They don't have to be fixed lists of parenthesized values. For instance, say we'd like to list all course ID tables. Shift back here to courses 2. All course ID values from table section in courses 2, where the section is for a term that ended after September 1st, 2012. This query will accomplish that. It produces a list of IDs for terms that ended in the subquery here after the date in question. And then the where clause checks to see if term ID is in that list. And there's what we get. Any subquery may be used this way as long as it returns rows with a single column. And there are a number of other types of tests you can do with value lists, whether it's subquery generated or constant. For instance, let's list the kind and flavor and price for products that are more expensive than all chocolate-flavored products. I'll switch back to Bakery4 there, and then run this query. Now the query compares price against an entire list of values supplied by the subquery. We can do relational comparisons of a scalar, like price, against a list, but we must specify any or all after the comparison operator. Specifying all means that the comparison, for instance greater than in our case, must hold for every single value in the list. Specifying any means it must hold for at least one of the values. So the example query requires that the price of our product be greater than all prices of chocolate-flavored products. And there we go. By contrast, if we do the same query, but replace greater than with less than, and all with any, then what we'll get is products whose price is less than at least one of the chocolate products, which is a rather larger list, as you can see. You may use any relational operator for comparisons like this, along with an any or all modifier. So question 2. Find all products whose price is at or below at least one of the prices already paid by customer number 2. The point would be to find products within his or her price range, which we assume would be any product that is no more expensive than something they've already bought. Now, start with a subquery to get all prices paid by the customer thus far, and then choose the right relational and all or any choice for comparing with the list generated by the subquery. And returning from a pause there, this is what I came up with. The subquery selects from receipt, line item, and product the price for any product that belonged or was purchased by customer 2. And then we're checking to see that the price of the product at the outer query is less than or equal to any of those others. And there's the list. Now, there is also one more operation, exists, which tests whether a subquery list has any value in it at all. So here's a query returning rows for products whose price is cheaper than at least one chocolate-flavored product. The subquery gives rows for all chocolate-flavored products whose price is greater than P's, and if any of these exist at all, then the where is true. The exists test then is asking whether or not there's any item in this list. And then finally, both in and exists may be negated by using not in and not exists, though these are just conveniences, since one may always use the general not operator to get almost the same syntax. X not in select some list is the same as not X in select some list. Question 3. As we add new features to SQL, we'll see more and more cases where the same query may be written several different ways. Rewrite the chocolate query here without using exists by making a really small modification to the subquery. Coming back from the pause, we really don't need to first run this, and then we really don't need to do an exists, because we could just do a subquery to get a count of those products and then ask if the result of that is greater than 0 or not, and get the same result. By the way, even the greater than 0 is technically superfluous, since a value of 0 counts as false. Now, the exists might allow more efficient implementation, since it makes it clear that the subquery may stop after finding the first matching row, rather than counting all matching rows. But it doesn't do anything different logically. The subquery generating a list may be arbitrarily complex. Here's an example that requires a more sophisticated subquery. So, question 4. Write a query to list kind and flavor for all products not discounted on 2007-1026. Make no assumptions about the present content of the discount table, and don't use an outer join, even if you might know how. Instead, write the query two ways, one using an in and one without using an in. So a good answer would be select kind and flavor from product where ID not in, and then you can see that this version has a subquery that generates a list of all the product IDs covered by discounts that were in effect on the date in question, and it's checking to see if our ID is not in that list. And the result is there with 35 rows. The other alternative that you might have come up with was to select kind flavor for product where, and now we are checking to do the same thing really, but we're using ID not equal to all to see that it's not in this list. Not in and not equal all are effectively synonyms, as are in and equal any. Okay, let's look a bit now at how list subqueries can be replaced with joins. There's the result of the earlier query, by the way. We're going to shift to courses 2 here. This is a useful way to reinforce both concepts, to look at subqueries and joins, and to give you a choice of how you implement complex queries. So, again, moving to courses 2, start by rewriting, and I'll show it to you in the notes here, this query without use of a subquery. Instead, just use a join. So we want select distinct course ID from section where term ID is in, and there is that select. It's pretty obviously convertible to a join if you think about it. So a good answer to this would be select distinct course ID from section, join term on term ID equals term.id, and then the end data specified. And there's the result. Okay, let's try another one. Rewrite this one without subquery using bakery 4 now. And you'll need to join between two aliased product tables and a group by. You can see what this is doing is giving you the kind, flavor, and price of a product where its price is greater than any, meaning, of course, to be exact, any one product whose flavor is equal to chocolate. So as long as it's greater than somebody who's chocolate, it's good. So a reasonable way to do that in bakery 4 again is to do a select on two copies of product, P1 and P2, and P1's price must be greater than P2's price, and P2's flavor has to be chocolate. We'll group on P1 ID so we don't duplicate, and then we'll be listing P1's kind, flavor, and price. And there's the output for that. Okay, not all conversions are this easy. If the query we just did, for instance, had used all instead of any, then it would have required use of an outer join, a concept that we'll get to later. But while we are looking at redundancies, let's also see how to trade all for any and vice versa. So with that in mind, write a query, again on bakery 4, that is the equivalent of this one. Select kind and flavor and price from product where price is greater than any, as we just said, that is greater than chocolate, the same one we were just looking at. And stick with the subquery design, but rewrite it without using any, replacing instead with all and two other changes. And do remember that any logical expression, including list tests, can be negated with an exclamation point or with the keyword not. So this is a reasonable answer. Select kind, flavor, and price from product, where not product price is less than all of select price from product, where flavor is equal to chocolate. So if it's not less than or equal to all of them, then it must be greater than at least one of them, and thus the effect is the same. The any and all operations are complements of one another. In what is actually an application of something called De Morgan's laws, you can always rewrite an all test as an any test, and vice versa, by reversing the comparison and then negating the entire test. And there is the result of that query. Now, one last point here. While it's much less common than simple lists, one may also use subqueries that return several columns as a sort of list of tuples, a list of sets of columns, also viewable as a table, in fact. You may do in-tests against a multi-column list using a fixed value parenthesized tuple as kind of the scalar. Here's an example that finds all customers whose first and last name are a match with some other customers. As you can see, the subquery here returns a list of two-column rows, which are compared against the first and last name. If any tuple in the list matches both attributes of the comparison tuple, both columns, then the in is true. In our case, in fact, there are no such matching customers.